Dear students, we are discussing exercise 7.11, that is to solve definite integrals by using the properties of definite integral. And the question 10 is find the integral of integral 0 to pi by 2 twice log sine x minus log sine 2x. Now let I equals to integral 0 to pi by 2 log sine x minus log sine 2x dx. Now which implies that it is integral 0 to pi by 2 log sine x minus integral 0 to pi by 2 log sine 2x. This simply becomes twice integral 0 to pi by 2 log sine x minus integral 0 to pi by 2 log 2 sine x cos x, because sine 2x is twice sine x cos x. Now we know that log m n equals to log m plus log n, or we can extend this formula for three terms, that is log log a b c equals to log a plus log b plus log c. Here a is 2, b is sine x, c is cos x, that is integral log 2 minus integral log sine x minus integral log cos x. Now here we have twice integral 0 to pi by 2 log sine x minus integral 0 to pi by 2 log sine x, that is simply integral 0 to pi by 2 log sine x. Here it is simply integral 0 to pi by 2 log 2x dx and integral 0 to pi by 2 log cos x dx. Name it equation first. We know that integral 0 to a f of x dx is integral 0 to a f of a minus x, that is I equals to integral 0 to pi by 2 log sine pi by 2 minus x minus integral 0 to pi by 2 log 2x minus integral 0 to pi by 2 log cos pi by 2 minus x, that is by replacing x by a minus x, that is pi by 2 minus x from first. That is I equals to sin pi by 2 minus x is sin x and cos pi by 2 minus x is sin x, which implies that here we get integral 0 to pi by 2 log cos x dx minus integral 0 to pi by 2 log 2 dx minus integral 0 to pi by 2 log sin x dx, that is second. Now adding first and second, we simply get 2i becomes here this log cos plus we have here log sin x minus, and here we have log sin plus and here log sin minus, so they will cancel. We simply get minus 2 integral 0 to pi by 2 log 2 dx, that is minus 2 log 2x, which is constant, it comes out from this integral, and integration of 1 is simply x, that is simply pi by 2, which implies that I is minus log 2 pi by 2, that is minus pi by 2 log 2, or given integral becomes minus pi by 2 log 2, or when we consider the positive value, that is simply pi by 2 log 1 by 2, because log 1 by 2 is log 1 minus log 2, that is simply minus pi by 2 log 2. Hence pi by 2 log 1 by 2 is the required value of this definite integral. Now the another question is integral minus pi by 2 to pi by 2 of sine square x dx. Here the given function is sine square x, and this can be written as sine x whole square, and sine square minus x is sine minus x whole square, that is minus sine x whole square, that is simply sine square x, which implies that sine square minus x is sine square x, hence it is even function. And we know that for even function, integral minus a to a f dx is twice integral 0 to a f of x for even functions. Hence minus integral of minus pi by 2 to pi by 2 sine square x dx is twice integral 0 to pi by 2 sine square x dx, that is this sine square can be written as 1 minus cos 2x upon 2. This 2 and this 2 will cancel, so we simply get integral 0 to pi by 2 1 minus cos 2x. Now integration of 1 is x, integration of cos is sine 2x upon 2 from limit 0 and pi by 2, because integral 0 to a integral a to b f is fb minus fa, that is pi by 2 minus sine twice pi by 2 by 2 minus integral 0 minus sine 2 0 upon 2, that is simply pi by 2, hence the given integral becomes pi by 2. But if we consider sine cube, and we know that sine cube minus x is minus sine cube x, which implies that it is odd function. So if we take the same limits, then its value is 0, because for odd function f, integral minus a to a f dx is simply 0, because when f is odd. Here sine cube is odd, that is why its value is 0. Now the another problem is find the value of integral 0 to a root x upon root x plus root a minus x dx. Let I equals to integral 0 to a root x upon root x plus root a minus x. Using property 0 to a f equals to 0 to a f of a minus x, that is where we are replacing x by a minus x in first, that is this very. Now adding these two, it is 2I equals to simply root x plus root a minus x upon root a minus x plus root x. So denominator and numerator same, cancelling we simply get integral 0 to a dx, that is x from 0 to a, hence it is simply a minus 0, that is a, which implies that 2I equals to a or I equals to a by 2, that is the given definite integral is simply a by 2. Another question is, show that integral 0 to a fx dx is twice integral 0 to a fx dx if f of x equals to f of a minus x, g of x plus g of a minus x is 4. Let I equals to integral fx gx dx, that is given. Using property, it is f of a minus x g of a minus x, because f of a minus x is here f of x and g of a minus x is g of a minus x. Now adding these two, it is 2I equals to integral 0 to a fx common, f gx plus g of a minus x. But this g of x plus g of a minus x is 4, so it is simply 2I equals to 4 times integral 0 to a f of x dx, that is simply I equals to twice integral 0 to a fx dx, that is, but I is integral 0 to a fx gx dx equals to twice integral 0 to a fx dx, hence proved. So inshallah in tomorrow's video lecture we will discuss the miscellaneous exercise. So thank you.